Hi guys, so in this video I'm going to be showing you how to determine the formal charge on every atom in a Lewis structure. So first off, what is formal charge? Formal charge is the hypothetical charge that an atom would have if we took all of the bonds and we broke them in half and the atoms ended up sharing the electrons equally. So what I mean by that is if we take a look at the nitrate ion as an example, if we take the bonds here, we have one nitrogen-oxygen double bond and two nitrogen-oxygen single bonds. We take them and we cut them in half, and in each of those bonds, half of the electrons go to the nitrogen and half of the electrons go to the oxygen. We end up with a situation that looks like this. So formal charge is just assessing what would the charge on the atoms be if this were to happen. Now, this doesn't happen. Formal charge does not represent a real charge in the molecule. All it really gives us is a way to keep track of our electrons in a structure. So formal charge can be really useful to us in determining the stability of a structure as well as some things about how it's likely to react. But it's important to keep in mind that there isn't necessarily a full positive or negative charge where we're writing these formal charges, that it's really just how we're keeping track of there's a little bit of extra electrons over here, a little bit missing over here, that sort of thing. So how do we actually figure this out? So again, if we look at this situation where we've broken our bonds in half and split our electrons equally, we're comparing how many electrons does the atom have in this scenario to its normal number of valence electrons, which is equal to its group number from the periodic table. So when an atom has more electrons in this scenario than is normal, its formal charge will be negative because it has extra negative charges around. When it has fewer electrons in this type of situation than it normally would, its formal charge is positive, and when the two numbers are equal, the formal charge is 0. So let's look at assigning, or how we would assign the formal charges to all of the atoms in the nitrate ion. So for the nitrogen is in group 5, so it usually wants to have 5 valence electrons, but we can see in this compound that there are only 4 when we break the bonds like this. It got 2 from the double bond and 1 from each of its single bonds. So that means we are missing 1 electron compared to what's normal for nitrogen. So it has a positive 1 formal charge, which is why there's a plus sign indicated here. The top oxygen is in group 6, so it usually wants to have 6 valence electrons. Here it has 6, 4 from the lone pairs plus 2 from the double bond. The numbers are the same, the typical and how many it actually has, so the formal charge here is 0. Now the two oxygens on the bottom, typical is still 6 for oxygen, but these ones have 7. They had 3 lone pairs for 6 electrons, plus they each got 1 from the single bond for a total of 7. They have 1 extra electron, so that is a negative charge, which is why we see the little minuses indicated on both of those atoms. So in the nitrate ion, we have a positive 1 formal charge on nitrogen, and we have negative 1 formal charges on 2 out of our 3 oxygens. So that's the general idea for how you assign formal charges. So I would like you to take a minute, pause the video here, and try to assign the formal charges to every atom in these two structures. So for the structure on the left, ozone, you should find that our first oxygen on the left has 7 electrons around it when we break our bonds in half. 6 from the lone pairs plus 1 from the single bond, so that is 1 extra compared to the 6 that oxygen likes to have. So we have a negative 1 formal charge on this oxygen atom. The central one only has 5 electrons around it, 2 from the double bond, 1 from the single bond, 2 from the lone pair, which is 1 fewer than the 6 that oxygen typically has, so that is a positive 1 formal charge. And the third oxygen on the right has 2 from the double bond and 4 from its 2 lone pairs for a total of 6, which is equal to the number that it usually has, so our formal charge is 0. For our other structure, carbon monoxide, you should find that the carbon has a negative 1 formal charge because it has 5 valence electrons, 3 from the triple bond, 2 from the lone pair, which is 1 more than the 4 that carbon typically has. And the oxygen has a positive 1 formal charge because it also has 5 valence electrons around it, which is 1 fewer than the 6 that oxygen typically has.